team of the morning, also a pharma team. This one is the second half of the team that we just had. They are showing a complete different item, but everybody was mingled around the solution of the previous design, as well as the other team was involved in this design as well. It's been a very good collaboration, and I think that has really developed a bond in between the electrical and mechanical department in ways that never happened before. I really appreciate the work. Team number 10, are you guys almost ready? Ready for the hashtag? Let me know when you guys are ready.
Yes, we're ready.
Go.
Good morning, everyone. It is an honor and pleasure for me here today to introduce the second project from Pharma Ii. We have FastPick. My name is Lin Wing. I have Jessica Corona from EE department. We have Joe Del Desiree from ME department. And today we're going to introduce some basic information about FastPick. We're going to go over some project description, background information, design evolution, mechanical as well as electrical design, economy feasibility, future modification, and conclusion. Let's just start with project description. As you can see right here, FastPick is a stackable system of locker that allow customer to check out their prescription without waiting in line for 1 up to 3 pharmacies that work in that shift, while ensuring high security of customer information. Now I'm going to back to Jess to go over some background information.
Thank you. Now, based on our research and interviews conducted with pharmacists, pharmacy technicians, and customers, we determined that there is a need for automation in retail pharmacy to remove error, to improve expediency of prescription delivery without compromising the safety and security of the patient, of course. So who here has stand in line in the pharmacy for way too long? Yes.
Too long.
Everybody. So based on a report conducted by the German pharmaceutical company, Boehringer Ingelheim, in regards to patient satisfaction in pharmacies. That report highlighted the satisfaction, the level of satisfaction and convenience in prescription delivery. Here we can see that the level of waiting corresponds to the satisfaction and convenience in picking up a prescription. So minimizing this time is a big priority for customers to stay in their pharmacy. On average, customers pick up or wait about 7 minutes to pick up the prescription. So if they have a question for the pharmacist, a consultation, usually that adds up to 5 more minutes. All of this accumulates and makes the waiting time even longer. Here we can see that about 33% of customers come back after they discover that the pharmacy has been closed. So they usually come back the next day, wait in line again. And then about 19 go to a different location altogether. So a device like this would definitely facilitate how they pick up their prescription after hours. Most retail pharmacies are located inside a bigger chain store, so they're open for shorter periods of time than the general store. And if this was implemented in that store, the patient would still be able to walk inside the whole store and pick up their prescription. Here we can see that 37% of customers express that they base their visit to the pharmacy on convenience, of course. So if they're waiting for too long, they will probably not go there again. Here we can see a map of Walgreens pharmacies in Houston. We have about, I would say, 10 or so that are 24 hours. And we have about 100 that are open regular store hours, which is about from, I would say, 10 a.m. to 10 p.m. And like I said again, these stores are located inside bigger chain stores. So this, if it were implemented, it would allow the customer to come in still during store hours, but after pharmacy hours to get their prescription and check out. Currently, we see Amazon lockers as an indirect competitor. They're not really in the pharmaceutical industry, but we share the same concept of self-service checkout.
So during our initial design process, we were facing the following challenges. First is the safety and security of prescription medications. How do we ensure that medications being stored in the locker are safe and secure? Second is customer convenience. How do we make the locker easily accessible as well as user-friendly? And third is an innovative stackable design. How do we design the locker for easy assembly and disassembly while maintaining the material's integrity? So for our initial design of the locker, we built a 10 by 10 locker. This is this one with 1-inch thick walls. And we integrated male and female connectors on the sides as well as sliding connectors on the top and bottom. These are to attach the lockers together. For our initial door design, we incorporated a spring mechanism on the hinge, which serves as the hinges. And we also implemented an electromagnetic lock, which serves as the main locking mechanism of the locker. The side panels are used to fix the lockers in place. Here is our first prototype. We utilize 3D printers as well as PLA as our base material to build this prototype. Here's a short video of our prototype. As you can see, the customer is inputting all the required information. And once all the correct information has been inputted, the locker will open. And the customer will be able to collect his medications. During our testing, we identified some shortcomings. First is the size of the locker. It is quite large and would require an ample amount of space. Second is the spring mechanism on the doors. And third is the, as you saw in the video, the wires are disorganized. So for our new locker design, we built a smaller locker, which you can see on this side. And we replaced the spring mechanism to hinges, as well as we integrated some wiring systems on the side panels to neatly secure all the wires. Here's our second prototype. We still use 3D printers and PLA as our material to build this product. For our final design, we incorporated 4 lockers and 4 side panels and 4 top and bottom panels as one final product of the FastPick.
So now we're going to go over some electrical design of the system. As you can see, we divide it into 2 parts. The first one is hardware and the second one is software. So here is the bigger electronic system wiring diagram of the overall system. As you can see, FastPick gonna have 2 sides, one for customer and another side for our pharmacy staff. Each side is controlled by a Raspberry Pi. They're gonna connect it to a 7-inch touchscreen LCD or a regular desktop monitor. As you can see, for the prototype, we have 4 units in total. Therefore, we have a magnetic lock. To control it better and more efficiency, we use a unit relay. And to support for the whole overall system, we have the power supply of 12 volt 2 amp. So here we're gonna go some specification of the overall system. You can find the power information as well as the required OS. We also have the dimension of the prototype. It's gonna be 14 by 14 by 6. Now we're gonna go over with the software design of the system.
So this is the beginning of our graphical user interface. This is pretty user friendly. Would pretty much prompt the customer at every frame. So this first frame begins with already paid or must pay. So the customer has the option of paying either at home through the app, pharmacy app, or online, or they can come in the store and pay at the register. So if they've already prepaid, they'll go to this frame and it would prompt them to enter their name, date of birth, and passcode, or it would have them scan their barcode, which was generated after payment. If the information is correct, the locker will open, giving them ample time to get their prescription and close the door. If the information does not match, though, it will give them an error to seek further assistance. If they need to pay in the store, they would go to this frame. So here they would put their billing information or swipe their card, and it would also open just the same. Currently, we don't have any cash paying options. That would be a future implementation.
Good. So when narrowing down what materials that we wanted to use, we narrowed it down to plastic, aluminum, and stainless steel. Plastic because it's economical, it's pretty cheap. Aluminum because it's durable, ductile, as well as non-corrosive. But we finalized our decision to stainless steel. Stainless steel has every material property that we wanted from aluminum, as well as it being a stronger material. As far as the finite element analysis goes, we wanted to simulate a couple of different scenarios and forces to act upon our object. This is assuming that the door of the locker itself is completely constrained and attached to the unit itself. And we wanted you guys to easily visualize how this would look like. So in the following slides, we'll have the computer-generated image of the FEA analysis next to what it would look like in real life. So there's a pretty big, strong guy. If Derek swings a blunt object at the locker door, if he applies 10,000 pounds, the safety factor would come out to 1.5. Dale really isn't as strong as Derek, so he has to use a little lever of a screwdriver. If he applies a load of 1,000 pounds, the safety factor would come out to roughly 8. And finally, Mikhail. Mikhail doesn't really like using tools or whatever, so he would decide he would resort to pulling on a steel door, I guess. With pulling force of 250 pounds, he comes out with a safety factor of 9.3.
For the economic feasibility cost, we have considered the fast pick would be placed inside of the pharmacy. The material that we would use is stainless steel, as Joe mentioned, and the process would be computer numerical control, that is CNC. The main reason we're using CNC is because it is an accurate and precise method, and as you see, we have really special features and small parts in our project. The main cost estimate that we got for the project are the cost of the prototype, that it is $49,000, and this includes marketing, manufacturing, parts, and also the labor cost. And we also got the mass production cost, that it is $516 for the final design. For the future modifications of FastPick, first we will plan to do a consultation option for any doubt that the customers can have. We have reached out to all the customers and to some of the customers and to the pharmacists, and that was one of the main concerns for our project. Also, second, we have planned to implement temperature control units for special medications as insulin and birth control. Third, we plan to replace the actual magnetic lock we have right now for a mechanical lock, because that would increase the security, and it also empower, if we have power outage or like in fire hazard, that would be really helpful. And it will decrease the electrical cost. We also plan to change the hinges and to have a door closer for the locker. And finally, we plan to implement a new method of payment for cash, as Jessica mentioned. Then I will pass it to Lee.
With all of the explanation and technical information and technical explanation that we have above, we strongly believe that FastPick is going to be a significant product that help retail pharmacy solving a lot of problem and issues that they are facing right now. So here is some of the benefit that I can conclude. Number one, fast. Customers do not need to wait in line for 1 or 2 pharmacy staff to check them out. They can do it themselves. Number two, convenient. Customer can pick up their prescription whenever they have time, maybe after work, when the pharmacy already closed, or during holiday. Security, we are thinking to hiring a third agent company to taking care of the ID as well as payment transaction for us right now, because as an engineering student, those resources are required. So last but not least, this is the very unique way that we find out right now available in the market that for customers to pick up the prescription. So now I'm gonna show a final video demonstrate how the overall system that we have this semester. The video that we saw earlier is for customer side. Here is the pharmacy side. You can see that here's the pharmacy side. Try to log into the system. She's gonna input the username. It can be work email as well as the password. Since she logged into the system, there's 2 ways that she can do. It can be manual or use the scanner. Here is the manual way. She can put her first name, last name, as well as employer ID. So for that, one of the locker available right now can open, and she can place the bottle inside. It's gonna be 2B in this case. She is checking the other lock is still like the only open is like 2B, and she can place the bottle of prescription in there, and it's locked right after that. So with all of that in mind, thank you very much for your time listening today, and please let us know if you have any questions.
Anybody? Okay.
You run a finite element analysis on this, and you have safety factors.
Yes, sir.
What is the safety factor related what to what?
Related to, what do you mean?
The safety factor is a ratio.
Right.
Of what to what in your system. When you say I have 1.5 safety factor.
Oh, right. So this related to the maximum von Mises stress compared to the yield strength of the material. trying to hit the door open to try and get it open.
Okay.
Yes, sir.
So relate that to the safety factor.
Relate. I'm not sure I answered that question, sir.
Well, I'm trying to figure out first, why do I need, if anything, element analysis for this when it's not just static, it's just dead? And two, what is the safety factor we're talking about? So if I expose it to 10,000 pounds force hitting, what does the 1.5 tell me?
So if I may interpret that professor's
Yes, sir.
question, I think the 10,000 pound 1.5, you have based on the real data. All the industry using 1.15. Why you pick 1.5? Why you even pick up 10,000? That's linking back to your design specification. What is required to test to pass the performance requirement, right? So this 1.5 is arbitrary number. It really based on the empirical data, depending on which industry you work on, right? Some only 1.15, some on 1.25, 1.5. I don't know how you guys pick up 1.5. I'm just curious.
I have even a more fundamental than that. That's the next level. First level is what does that mean? Second level, how do I judge that it's acceptable? And even more, at a lower level, and I'm not going to ask you for an answer actually, take it with you and think about it. Do I need FEA really for this? I don't want an answer, think about it. Later on we can take it offline. Thanks.
Thank you very much for your questions.
May I follow up with the question?
Yes, sir.
First of all, wonderful presentation, wonderful project. And I think your team so far, I didn't attend every team presentation. This is the team I'm impressed the most. You did the marketing analysis. You actually identified the need. You identified the pharmaceutical hours, the availability of time. So really you're addressing when the pharmacy, they are off the hour, you're providing convenience for the consumer. Wonderful. I think I love this one. So anyway, marketing study, you have it, really good. So the only question I have really from the technical point of view is the input. Have you guys thought about the eye input and also the fingerprint? To me, that would be more secure, right? Because anybody can hack into the system by putting into the username, password, all that kind of thing. Have you thought about using the eye input and the fingerprint?
Yes.
Yeah.
We did think about what kind of added security the pharmacy itself would need to implement if we used a device like this. Maybe say in a bank or in an ATM when you're trying to get your money out, it has a camera pointing at you. So this is something we thought about, we just didn't add it because that would be a future implementation. That's not something that we can do right now. But we did do maybe a camera either pointed from the register to whoever is checking in, or extra added security to pointed to the lockers. Also ID, we thought about maybe ID just right now to check out a prescription, you need ID for controlled substances. So if we use this, we're like, well, maybe use ID for everything.
Just add on to it because we started this project last August, and then which is like 9 months ago. We have a lot of limited of resources, and then we decided student level we don't have a lot of time to do so. But after come back from the competition in California, we have adapt a lot. We meet a lot of great people over there to aspire and open to a new way to make the modification better. So of course, yes, thank you, Dr. Shea. We keep that in mind, and we are seeking for grant as well as sponsorship right now to make the product become a real life product. And hopefully, maybe one of us here gonna use that in the future. But yes, we're gonna demonstrate and also modification that in a real future modification. Yes, sir.
Dr. Royce.
So I meant to ask, this is really for both groups, but y'all are off the hook. So you spend a lot of time with your branding and y'all look great. You're at the good looking portion of your life. Why wouldn't you put that into your cookie? Incorporate those elements into your cookie?
Like ID,
Fast picking.
Logo.
I'm not really understand the question. Can you say it again, please?
So you got your login screens, the web-based login screens and that number, and your branding looks great. Why wouldn't you incorporate those elements into your login screens?
All right.
We actually did try to input the logo as well as GT Tyler logo on the regular desktop monitor. We actually come to one of our team member, Hal Gara, last Saturday to try to do that. And we are thinking to have a coding for that. We try to have it, but so far what we achieved is just the regular monitor, and then we just have a blank space right there instead of the logo. It's like just a blank white box right there. I think we need more time to working on it because we kind of running out of time due to the trip and all that. But yeah, yes, definitely. We would love to put the fancy logo that we have in there as well. Yes, sir. Thank you for your question.
The electrical side, what kind of processor do you have in there?
Raspberry Pi.
Why?
Well, we found that it has its own Bluetooth, it has its own Wi-Fi. It works as a pretty good computer, as a low-cost server. So, and it's something that's already available to us. So
how many
wanted to
I/Os do you have in that system that go to the Raspberry Pi? Inputs, outputs, how many lines do you have?
Right now, as a prototype, we have 4 units in total. Therefore, we have a magnetic lock. So that's why we have a I/O together. But for the future, we are thinking to design our PCB board. So that's where we have more advantage to control how many locker that we want. Yes, sir.
Yes, sir.
All right. I enjoyed the presentation. I think you did a good job also explaining the problem with wait times. I was curious as to, with this process, did y'all get into a conversation, or maybe I missed, about how much this is going to improve the current wait times that people are experiencing?
Yes, we did some interviews about probably 5 pharmacies, pharmacists as well as pharmacy techs, and they have told us that this would be helpful integrating into their system. It would make their work more efficient and more expedient as well.
Just a recommendation, because I know y'all presented this before, and that might be something to think about is, quantifying, or,
Yeah,
this
yes,
is a current
yes, sir.
issue, and, with this process, hardware, software process, we're going to decrease wait time by X%.
Yes, sir.
Yes, sir.
Thank you.
Thank you.
About wait time, does the system tell the customer when to pick up the medication?
Oh, the system right now, like I said, we have 2 sides, 1 customer, 1 pharmacy. When the pharmacy staff done to review the medication and they don't order, they can open one of the lock available, put it right there, and the system will automatically send out an email to customer saying that their prescription is ready to pick up. For the future, we're gonna do it with the cell phone, but right now we are not that level yet. So if we just can send out an email to customers saying that the prescription is ready to pick up. I think one of the team already explained that, but maybe you don't get it. Along with the barcode or QR code. So that customers just come to the locker and use the scanner or even with the manual input to open the door that holding that prescription. So that is the way the system works right now.
So what if a customer does not pick up the prescription? Since it's not a controlled environment for starting medication, what do you do with that medication?
Right now, what current pharmacies do is if it's a new prescription, after 1 week, it gets put back. If it's a refill, it gets put back in 2 weeks. So with this, since I feel like not every prescription filled is going to go into one of these, I would say a range of 2 to 3 days it could stay in here and then it gets put back.
So this sounds like online orders, like a Kroger or Walmart.
Yes, sir.
You can go to the special line to pick up your stuff.
Yes.
So to me, this is a supplementary system, not a replacement system, right?
Yes, sir.
So it's doing something better.
Yeah.
Yes, sir.
Right?
We try to help the checking out process as well as save time for pharmacy staff.
Very good.
In the app that they're using or in the system, do they have access to their full history? Like, so 2 weeks ago, it'll show when I picked it up?
Currently, the app, I know how the app works at CVS. It shows them probably a history for maybe 2 years, 2-year history,
Oh, I
because that's
see.
how much records.
Does your system know all of that?
So this is something we would love to implement with the system that already exists. That's
Is there
something.
any consideration of using blockchain to manage that? Because then you could push them a token and when they pick it up, it would have an authentic key.
Hadn't considered that, but thank you.
Yeah, we
Yeah,
can
it's a
consideration. Thank you.
Any other questions? Would the system be able to work exposed outside directly, not inside a store? What modification would need to happen?
Well, yeah, it would be able to work outside the store. Maybe we just have to like get more cameras, secure cameras, and like it's stainless steel. So yeah, like as he explained, the material is efficient enough to be outside.
Yes, that would be a future modification for it. We have considered putting it outside of the either Walmart or any other pharmacies as well. That was our main intent. However, we could see some limitations to that for now, because the electromagnetic lock would not be able to withstand that ample amount of force. That's why we would choose for mechanical lock. But yes, we have considered putting it outside of the store as a wall or as an ATM machine for that.
Yeah. So you're also assuming that the customer is already paid, right?
Yes, sir.
Yes,
sir.
something
Yes.
that we would love to implement that, because the system you can either pay at home or pay at the store when you pick up. So that the option of paying at home, like increasing the ability that the customer must go to pick up. So the staff do not have like spend their waste their time there, just like filling something that nobody wants. So this is another benefit of the system.
So that was an excellent question from Dr. Garcia, because I thought about the same kind of question. I was asking the question before this presentation.
Yes, sir. Yes.
Why you reinvent the wheel? You can use in something like ATM machine.
Yes.
The ATM machine today is a direct interface inside of the bank, right? Or this can be like Walmart or whatever. You already have a design.
Sir.
You already have the environmental protection already.
Yes, sir.
You take the credit card, pay it,
Yes.
and you can dispense. And somehow you can retrieve it. Right?
Right.
So, but this is the wonderful thing. For engineering project, I think this is wonderful. But in the real world, when you get into commercial world, and you have to consider what you already have it and do the improvement. Right?
Yes, sir.
Yes, sir.
But this is absolutely a wonderful project.
Thank you very much.
Thank you.
One final advantage that they mentioned to me, but they didn't show it, you know, one of those things. One of the main advantages that I see, you know, that they were discussing is the fact that they might have some lockers available for, let's say, oxygen or diabetes pill, so that people can access at any given time or in case of emergency just by coming with a recipe, logging in, and having the availability 24/7 of very precise medications. Okay, that will save a life, improve the quality of life of anybody. So that point, I think, it's also not only of pills that or medications that they need to be delivered, but also some essential items that currently, I mean, you need to go into the emergency room in order to get, and we know what it takes into an emergency room. Never mind. Any other question? Yes, sir.
Yeah, like during Harvey, the store was closed, all the stores were closed. So your system will work during those time, like if is there an emergency, during something from the store, like you don't need a prescription for those medicine. So like regular Tylenol or something, is there possible to do those things? Like for regular customer, if they don't have access to login or anything,
For
so they can just type like a red box, they can go in and.
For our system right now, this is a two-door. This is for pharmacy side and customer side. So we wouldn't be able to apply it for Harvey, because if the pharmacy is closed, then there will be no pharmacies inside to actually put the medicines or the prescriptions into the locker. So for emergency situations like a storm like that, we would not be able to implement or work this locker for that.
Thank you.